Good morning, Year 10. Today we're going to be going on with factorising expressions, but before we do that, we're just going to go through some revision questions of what we learnt last lesson to see if we can remember what we have already learnt. So 3 random things taken from last lesson's exercise. The first one is a perfect square expansion. So to expand this, we want to times 2x by 2x, which will give 4x squared. Then we times the 2x with the minus 3, which is negative 6x, but we double that to make negative 12x. Then we do minus 3 times minus 3, which makes a positive 9. The second question, we have a double bracket, but the brackets are different, so this is just going to be a FOIL expansion. So 4x times 2x will make 8x squared. 4x times 1 will be a positive 4x. Minus 3 times 2x will be negative 6x, and minus 3 times 1 is negative 3. The middle terms are like terms, so I'm going to collect those up. We'll get 8x squared. 4 minus 6 is negative 2x minus 3. Part C is a harder one because it has 2 different things that we need to expand before we can collect them up. So the first set of double brackets here will be a FOIL expansion. 1 times 2 is 2. 1 times 3x will be a positive 3x. Minus x times 2 is minus 2x, and minus x times 3x would be negative 3x squared. Then the second part of this question is just multiplying the minus 2x into that final bracket. So minus 2x times 3x is negative 6x squared, and minus 2x times 3 would be negative 6x. With all that expanding, there are like terms that we can collect. So I'm going to start with the x squared terms. I have minus 3 minus another 6, so that is negative 9x squared. Then I have 3x minus 6x, which makes, and minus 2x, nearly missed one. So 3 minus 2 is 1. Minus 6 makes negative 5x. And finally, the only term that's left is the 2, so plus 2 on the end. Okay, so that was our revision part. Moving on to new things, which is factorising. So factorising, in its most simplest form, is where you take out a common factor. So if we have something like 2x plus 6, 2 is the common factor, and then we divide each term to put the leftovers inside the bracket. So 2a divided by 2a divided by 2 would just be a, and 6 divided by 2 gives the 3. Okay, so there are other types of factorising, though, that you have learnt about, and there's a list of them here. So taking out a common factor was the one we just talked about. We could do a difference of 2 squares. These ones have 2 terms that are usually in the form of something squared minus something else squared. Grouping in pairs are the ones that have 4 terms. We have a monic quadratic trinomial. That is when you have something like x squared plus 5x plus 6. So you have the 3 terms of a quadratic, but the coefficient of the x squared is a 1. Whereas a non-monic, which we won't be learning today, we're going to do that another day, would be something like 3x squared plus 5x plus 2. So you have a number in front of that x squared. Okay, so we need to know all those types, but we're not going to do that last one today. We're just going to do the first 3. So let's go through question number 1. Factorise by taking out a common factor. So looking at my terms, 5m and 20, I can see that 5 is a number that I could take out of both of them. Then I'm going to open up my brackets and divide each term to get the leftovers. 5m divided by 5 is m, and 20 divided by 5 is a positive 4. Close the bracket. Part B, negative 4d minus 10. Negative signs can be factors, and if they're in both of them, you really should take the minus sign out the front as a factor. 4 and 10 can both be divided by 2, so that's minus 2 as my factor out the front. Now dividing each of my terms. Minus 4 divided by minus 2 makes a positive 2, and I'll still have the d as well. Then minus 10 divided by minus 2 will make a positive 5. So that sign in the middle of that bracket there does need to be a plus sign. Question C. 30 and 20, both of those numbers can be divided by 10. But there is also an m that is in both of those terms, so I can have letter factors as well. Opening up the bracket, 30m squared divided by 10m will be 3, and there'd be 1m in the bracket because the m squared means there's 2 of them, one's out the front and one will still be inside. 20m divided by 10m, 20 divided by 10 is 2, and the m from that term is going out the front. Question D. You can see that there are brackets in this question already. We don't want to expand them. Remember, we're trying to factorise. So we have 2 terms here. This is the first term and this is the second term. Both of those terms have x plus 2 in brackets in the term. So that is my factor that is coming out the front. Then I'm going to open another set of brackets and the remainder of each term is going to go inside. So if the x plus 2 has gone out the front, that means this 2 needs to go inside the bracket. In the second term, the x plus 2 has gone out the front, so the 3x needs to come into the bracket, and that is how you completely factorise. Moving on to question 2, these are the difference of 2 squares. So you can see in each of these, they all have 2 terms in them, even the slightly funny looking one in part D there. And there's always a minus sign between the 2 terms. To factorise these, they are going to always go into 2 sets of brackets, 2 brackets like that. You square root the first term, so square root of a squared is a, so it'll be a at the beginning of both brackets. Then you square root the 16, which is 4, which goes at the end of both brackets. One will be a plus bracket and one will be a negative bracket. Doesn't matter if you switch them in the opposite order to me. Let's do that again. For B, again, these are going to have 2 sets of brackets there. Square rooting 9m squared would be 3m at the start of both brackets. Square root of 4n squared would be 2n. And then one's a plus and one's a minus. Now, question C, even though it's not very nice, because we're going to have to use surds here, this is still a difference of 2 squares. So here's my brackets. Square root of x squared is x, so that's at the beginning of both brackets. Square root of 8, unfortunately, doesn't go nicely, so I'm putting square root of 8 in there. 1 a plus, 1 a minus. However, square root of 8 is a surd that can be simplified. Square root of 8 is the same as square root of 4 times square root of 2, because 2 times 4 makes 8. The square root of 4 is 2, so it is 2 root 2. So an even better answer would be to have x plus 2 root 2 and x minus 2 root 2, because then I have simplified surds in them. Part D, I do have something squared minus something else, so I can still use a difference of 2 squares here. So in my bracket, the square root of x minus 3 in bracket squared is x minus 3. So that's the beginning of both brackets. The square root of the 7 is square root of 7. Then I'm going to have a plus in the middle of one and minus in the other. And it doesn't look very nice, but that is the best answer that I can give for factorising that. Question 3 says factorising by grouping in pairs. Now these ones you can identify because they have 4 terms in them. What you want to do is you want to take 2 terms. So I'm going to take the first 2 and take out the common factor. So I can bring an m out of those 2 terms, which would leave n plus 3. Then the third and fourth term, I want to bring out a common factor, which would be a positive 3, and the leftover would be n plus 3. Now, if you've done this correctly, you'll see that the 2 brackets are the same, and they can now make a common factor that will come out the front. So n plus 3 is the common factor, and the m and the plus 3 from the front of those brackets, they go into a second bracket of their own. Let's do that again. So these first 2 terms, I can bring out a q as a factor. That leaves 10p and minus 1. Then from the third and fourth term, I could bring out a 2, but if I did that, if I brought out a positive 2, I would get a negative 10p in here, which is not good. So instead, what I need to do is bring out a negative 2 as a factor, so that it becomes a positive 10p there. 2 divided by minus 2 would make a negative 1, and now my bracket's the same. So I had to be a little bit clever there, bringing the minus sign out so that my brackets ended up the same. Now, the 10p minus 1 comes out the front to be the common factor, and the q and the minus 2 go into the second bracket. Again, it doesn't matter if you do switch the brackets around. Part C, 2xa minus 9 and minus 18a plus x. If I was to do the first and the second term, there is no common factor. So sometimes it may be better to pair up your terms differently. I could take the first term with the last term, for example, and there would be a common factor of x. So x bracket would leave 2a and a plus 1. Moving on to the middle 2 terms here, I would have negative 9 as a factor. And to make it look the same, I'm going to do this term first. So minus 18 divided by 9 would be 2a, and then negative 9 divided by negative 9 would be a plus 1, and my 2 brackets are the same. So my final answer, I bring the 2a plus 1, which is the common factor, out the front, and then the x, take away 9, will go into its second set of brackets. Now, question 4, if you've managed to get through questions 1, 2, and 3, question 4 is my slightly harder question, where I'm combining a few different skills to try to factorise these. So in 4a, you can see I do have 2 terms, but before I do a difference of 2 squares, I actually need to bring out a common factor first so that I can do it much nicer. So the common factor in both of those terms would be 4. So 4 out the front, I'm going to open up some square brackets, and that would leave x minus 4 in brackets squared minus 12. Close the square brackets. Now the inside part is going to be a difference of 2 squares. So the 4 sitting out the front, I'm going to have 2 sets of brackets to do the difference of 2 squares. Square rooting the x minus 4 squared will be x minus 4 at the start of both brackets. Square rooting the 12, unfortunately, is not very nice. So we have square root of 12 and square root of 12. One will have a plus sign, one will have a minus sign. Square root of 12, I mean, that is an answer, but square root of 12 can be a little bit nicer. It is square root of 4 times square root of 3, and the square root of 4 is 2, so it's 2 root 3. So a more simplified, or simplifying the third, we get 4 bracket x minus 4 plus 2 root 3, and x minus 4 minus 2 root 3. Question 4b has 4 terms in it. But the trick here is if I try to do the first and the second term, there's no common factor. I mean, I could get a common factor with those two, which I will do together, which means that I need to get the x squared and the minus y squared together. X squared minus y squared, those green ones there, are a difference of 2 squares. Factorising those green ones, I would get x minus y, x plus y. Then, factorising the 2 yellow ones, I can bring a 7 out the front and have x plus y. That means that the x plus y is a common factor in each of those terms. So the x plus y comes out the front, and that means the x minus y from the first term and the plus 7 from the second term will go into the second bracket. All right, we're all ready now to do exercise 8b, please.